Hello everyone and welcome to part 6 of Python programming series. I am Ram Prasad Pujari. In this particular session we'll talk about Python libraries. Python is very popular and widely accepted programming language. It is used for different application domains. Some of them are listed here. As you can see, web development, data science, software development, machine learning, embedded systems, and numeric and scientific computation. So these are some of the uses of Python. The Python is widely used for these application domains, and I have highlighted a few of them because in this programming series we will learn about how Python is useful for machine learning, for programming embedded systems, as well as for numeric and scientific computation. So this is what we're going to see in this. And so we also know that why Python is so popular, why it is widely accepted, widely used programming language. We discussed this in very first session of Python programming series. So, but one of the important reasons here is it supports wide varieties of libraries. So here we are talking about the external libraries. So you are free to install those libraries, depends on the application domain which you are working on, and after that freely you can use them. I have left few of the advantages as blank here because we already discussed them. Now for this session, what is important is the support that Python gives to all the different libraries. So if you want to work on machine learning, then identify those libraries, install them, and then you will be able to use them. Now as far as this session is concerned, we will focus on Python libraries. There are a number of libraries that we will be studying in the next few sessions, and this is different from the Python standard library which comes with your Python installation. In the last session, we discussed about Python standard library, some of the modules there, which includes a math module. So there you don't have to install them because those modules are part of Python standard library. But here we are talking about some of the libraries which you need to install separately. And depends on the application domain, we can identify and we can install them. For example, if you want to work on numeric and scientific computation domain, then you need some libraries like Numpy, which stands for numerical Python, matplotlib, scientific Python, pandas, etc. And similarly, if you want to work on machine learning, and these are some special libraries which we call it as frameworks, we'll study about these libraries later in some of the sessions. But as far as today's session is concerned, our focus is on the first library I have highlighted in red color, which is called as Numpy, stands for numerical Python. So this particular library we are going to look at in this particular session. And this is part 6. Part 1 through part 5 covers the basics of Python. We discussed about how to use Jupyterlab and introduction to Python, data types, and how to create your own function. We learnt about built-in functions, and also we looked at some of the modules, how you can create your own module in Python. So kindly watch those videos, and after that you can practice. There's a practical session. I'll be using Jupyterlab. You are free to use any other Python programming interface, but I prefer using Jupyterlab. I also recommend you to learn using Jupyterlab. So we are going to have so this is about today's session, Numpy. This particular library will have a look at, and this library has different functionalities to handle multi-dimensional arrays. When you're working on machine learning or data science or other areas, then you come across different types of arrays, maybe 2-dimensional or 3-dimensional arrays, and how do you store them and how you can manipulate. So this library will be very, very useful, especially when you are dealing with images, videos, and other type of arrays. And working with arrays will be faster way that will speed up your processing. So we'll discuss about this library today, and this is mainly used for multi-dimensional arrays. So the NumPy object is stored as a ND array. ND stands for n-dimensional array object. You can create and you can manipulate them. So we will look at some of the functionalities in today's session in the lab session, and I'll be using Jupyterlab for that. So let's move on to the lab session. So in this lab session, we want to understand the functionalities of NumPy library. So I'll be using Jupyterlab as I mentioned earlier. So this is the IPython notebook, and very first thing you are supposed to do is you need to install a NumPy, because NumPy is an external library. It is not part of Python standard library, so you need to first install it. So there are two ways you can install. One is you can directly install it from your notebook cell by giving exclamation mark, as you can see here, and you can use a pip command or the conda command if you have Anaconda installed in your system. So let me first install NumPy, and this is the command that you can use with an exclamation mark. So exclamation mark will allow you to run the pip command from here. Otherwise you can open a terminal and from there you can install it. So let me just run this particular cell. So now it is being executed, as you can see here, and so this I have already installed it, so it shows me NumPy is already there. Okay, so first you need to install it, and once you install this, the next thing you need to import this library, and you can reference it to np. So this is the command that you can use. So I installed, and after that I imported NumPy, and now I'll be able to use the functionalities of NumPy library. And in this particular practical session, I'm going to run the few NumPy commands, and which are listed here. Are course, this has got a large number of functions, but the few functions which are part of NumPy are also available under Python standard library, so I'm not using them. I have listed here, but these are the functions which I'll be testing today. So the first thing what we will do is we will create an array using Python, so not using NumPy, and just by running this particular code. So 1, 2, 3, 4, I'm just creating a one-dimensional array using Python code. So if I just check this A, so it's 1, 2, 3, 4. It has got 4 elements, and I can just use the command type A. It's going to be a list. As you can see, it is a list. So now I can convert this. I can also define a NumPy array. For that, you can just type np.array, np.array. This. So this will give me a NumPy array, and now if you look at this, you can see that it's a ND array. So it stands for n-dimensional array. So once you have a NumPy array, then you will be able to run some functions. So the functions like I can use n.shape, a.shape. A is a NumPy array object, so I can get the shape of this. This is having 4 elements, like there is a 4 element and it's a vector, and also I can reshape it. I can reshape this to any other matrix form. I can specify the number of rows and columns. That we are going to do it later. And so you can also get dimension of this particular array. So it says one dimensional array. This is one dimensional, or I can say this is a row vector. You can also get size of this particular array. So it has got 4 elements in this case. So like and I can if I look at the type of this, and I can also get the D type of this data type. So it's integer 32. So 32-bit number, and it's integer. So using 32-bit, you will be able to represent a very large number. And if the number, in my case, it's a smaller, then I can go for maybe int 8. So I can easily convert this into any required data type. So what I'll do is I will convert this into int 8 of a. So easily you can convert this into any dimension, any data type. So int 8. So now my data type will be db is the variable in which I have saved. So it's going to be int 8. So using 8-bit integer, you will be able to represent numbers from minus 127 to plus 127, something like this. And so that's the thing. So this is some of the functions that we can discuss. So we also have other functions like arrange or reshape functions. Now, for example, we have a vector, which is a Numpy array with one dimension. I can convert that into maybe a 2 dimension, and I can save it in, let's say, a dot reshape. I can type this way. Or 2,2. So now B will be, in this case you can see that I have reshaped it to 2 by 2 array. That means with 2 rows and 2 columns. So reshape is the function that I can use. And similarly, if you want to generate a sequence of numbers, then you can use a function called np.arrange. So you can use this, let's say 6, and let's say B, or maybe I'll just display it np.arrange, and you can see that this generates a number starting with 0 up to 5, the 6 elements. And there is also another function called as a linspace. I can use that function np.linspace. I can specify the starting number, that is, let us say 0, and ending number, and then the items that I want to generate, let us say 12. So this generates 12 numbers. As you can see here, the 12 numbers starting with 0, ending at 6, and there will be 12 count here. So these are some of the functions that we can use here. And similarly, so there is another function called as np.I, which creates an identity matrix. You can give the dimension of the matrix. So let's say it's a diagonal matrix. The diagonal elements are equal to 1. This is an identity matrix. So I can use a function called now, in engineering maths, we have come across Fourier representation, which is used for representing a function in the frequency domain. So in Numpy, there are 2 functions which are dedicated for Fourier representations. One is to calculate the Fourier coefficients, that is FFT. The second function will do the inverse operation. Okay, so I created a variable called as A, and which is nothing but Numpy array with 4 elements. I want to find the Fourier coefficient of this vector. So I can use the function np.fft.fft, of A, and I can print it. I can print B. So it's going to be, as you can see, that the Fourier coefficients will be in the complex form. So there's a real and imaginary term. So this is going to be 10. There are 4 elements here: 10, minus 2 plus 2j, minus 2, and minus 2, minus 2j. Similarly, if I want to get the inverse coefficient, like I can compute the inverse Fourier transform of B to get back A. So I can use a function called, let's say, C equal to np dot fft dot ifft of B, and so that will give me, okay, so that will give me, as you can see, that will give me the original sequence back. So I got 1, 2, 3j. Of course it will be in the complex form, but you can see that the imaginary terms are zeros. So let us summarize today's session. In this session we looked at the need for Python libraries. I also gave you a list of few selected libraries used for machine learning and numeric and scientific computation, and we focused on one of the libraries, popular library called as numerical Python library. In short, it is called Numpy. And after that we had a demo session using Jupyterlab to test some of the functionalities of Numpy. So thank you so much.